Welcome back to another episode of the Open Source Cafe. And today we have Sveta joining us from Memphis. Sveta, thanks a lot for joining. Would you like to
Hi.
tell us a little bit more about yourself?
Hi, I'm Sveta. I live in Tel Aviv in Israel with my family. I work in Memphis as the head of data in the company. You want me to tell about Memphis a little bit? Okay, so it's a real-time data processing platform that I founded with three of my friends who all studied together at the college, and we had a great project together. It was an open source project, and we collected tweets and analyzes discussions of influencers in any domain. It was great, and we had many collaborations, including Tel Aviv University and Open University. It was great, and we decided to make it bigger. So when we say make it bigger, it means in terms of scale and adding more data sources. So we found out it was needed something stronger than just our monolith, and we need some component, something to move data between our different components. So we tried to explore message queues, message brokers, and we found that nothing fits our requirements. Sometimes the onboarding was not so friendly. Sometimes the footprint was too high. Lack of community, and sometimes the technology was very, very old, and it was like many patches to make things work together. We needed something that works faster, that is lighter, that is with huge community around it, and that fits the modern data ecosystem, something that fits 2022. So we decided to create Memphis, which is a real-time an open source, which is a real-time data processing platform in app streaming use cases, which means when some real-time data coming to our platform, it analyzes on spot. So this is me, and this is the company.
Amazing, and that's what we're talking about today. Thanks for the intro. We're talking about data processing in various ways, like batch data and streaming data, real time data, like you mentioned for Memphis. So talk a little bit more, like for folks who might not be that familiar. What do we mean by, like, before we jump into the comparisons? What is what do we mean by when we talk about like stream processing and how it usually works out? So
Sure.
you get the data. So where is this data coming from, and why do we have this requirement to process this data?
Sure. So stream data is when we're talking about the big data world, data comes from many, many places. It can be from logs. It can be from people that enter our website. It can be from something that changed the database. It can be many things that happens in real time. And since usually the applications are more data driven and data based, so the data is coming from all over the place. It can be tweets and Facebook messages and WhatsApp and everything that we can imagine. It's a data source. So I think we must understand first the difference between stream and batch. So the difference is that batch, when we talk about batch, we usually take set of records together and perform some analysis. We can make a query out of database, have some collection of records together, and we can calculate the average, for example. When we're talking about data streaming, we're talking about an element that comes to us. We have it for fraction of time, and we have to decide what to do with it. So we can also analyze things like average, but we have to think about the matrix before, right? Because if we are having for example, I want to know the average of let's say people that entering our website. So I want to calculate the fraction of new users and old users. So I can calculate everything, but I have to know it before I can have I can sum this number and I can sum the other number and then divide them. But I have to know before. If I want to count, if I want to calculate average, I have to do the sum and after the count and then divide them. But I have to do it before, because after I saw this element, I won't see it again. So we can make same calculations batch on batch, and we can do the same calculation on stream. But in stream, we have to know before what we want to do and save the data in the side in order to calculate the things that we want. And actually, it sounds like batch is better, right? I can do everything on batch.
I think it depends on like the use cases from what I hear. Like if you're talking about batch processing, so it's like you mentioned data that has already been stored over a period of time. So this
Mm-hmm.
can be something like a billing system, for example, that is processed every month. And
Okay.
if you're
This is
talking
a
about
good use case. This is a good use case. Sounds like billing processing is something, billing system, something that we prefer to do the calculation on batch, right? But I'm not sure, because sometimes I have petabytes of data if I'm a bank and I store the transactions. So it's a huge amount of transactions, and if I want to calculate something, I'm going to the database, and I worked with the bank and made some analysis for banks. It takes hours. Sometimes you want to do some query and it takes like 10 minutes, and you sit and you wait for the query. And this is when I talk about few millions, but if I have billions of records, it's different. So batch is not always the better option, but sometimes we must do a batch processing, right? So we can use stream methods in order to make the batch easier. We can do some inline process and maybe to split to fuse the databases. Like if I have some transaction, I can on time do some calculation or think maybe, okay, this transaction came from IP of someone from bad list of someone who did some AML or something that I don't want to save the money in the bank, or I want to investigate. So I can do some process on this data while I have it in my hand, let's say, I call it like this. And then to think, oh, this is green or red. If it's green, okay, continue with the flow to the next component. Or if it's red, okay, maybe I'll check it with a different component and maybe I store it in the red database, which will make the process easier because I'm not storing everything in the same place. And then the queries will be lighter and faster.
yeah, cool. So yeah, I mean, it makes sense, and I think it depends on like the use case. Um, but I'll speak to you more around batch versus stream and why someone would prefer it, and if there's like a way to reduce this complexity that you mentioned in batch processes
Mm-hmm.
using like an like a stream platform. But before that, so for example, with streaming data, from what I hear, when we're talking about the performance, the latency does not have to be that much, like you mentioned, a few minutes or hours or whatever. I think minutes is also a really long time when we talk about
Mm-hmm. Exactly.
data processing in
Trying to respond to our
streaming.
client.
Yes,
Exactly.
for example, like you have let's say it's so almost like instantaneous. So for example, something like, what's a good use case for real time scenarios, like maybe stocks or um, fraud detection or something.
Fraud detection is a great example. Yeah.
Yeah. Hmm. Cool. All right. So that sounds good. Thanks for sharing. Now let's talk a little bit more about, because from what I hear, like uh, in terms of the performance, obviously there's some it's not as good as compared to stream when it comes to batch. But according to you, what are like some of the advantages? Let's go with the advantages first of batch and stream, and then we can talk about the disadvantages and how do you decide which one to go with.
Okay. So I think it's very, very important to understand what is the use case. Okay. And even if I think the use case is better for a batch, I can reduce the time complexity of the batch processing before. So let's okay, this is a different methods. I want to explain a little bit. When we study computer science or software engineering, we're always talking about time complexity, right? Our algorithm has to work fast and linear time. Okay, that's great. But when talking about big data, okay, sometimes when we have in our end our streaming element, okay, this is one element. So I can calculate and do some computing very, very fast because I have one element. I want to find out something about it. It's fast. When we're talking about streaming algorithms, and that's the thing that blew my mind when I studied about it, we're talking about space complexity. Okay, I want to know something about my stream and save something out of billions of records. In order to answer some questions, I want to know what is the average. I want to know how many records I've seen before, right? I want to know how many unique records I've seen. So if I have billions of records, I won't query the database every time and say, oh, okay, this element I saw before and this one I didn't see before. So it has to be, I have to save some storage on the side and then work with it. And the storage must be the smallest as I can, because this is big data. I can't have all the storage in the world. I have to have some small storage, and then to answer questions with this small storage. So this is the main switch in the head that we must think about when we are talking about streamings. So this is first thing. The other thing is, if we must work with batch, we can, as we said before, reduce the time. And reducing the time is enriching our data, is also make some stream process on our records before we store them in the database. There are many great solutions now. We have the data warehouses and databases and clouds and queries on huge databases that are very, very fast. But we can do it better. We can reduce the data that enters the database, or to add some fields, extra fields that make the queries easier. I don't have to say, sometimes we have select something that higher than average, blah, blah. It's very, very complex query. I can do some calculation. Let's say if I have tweets, okay, I can collect tweets and I want to know if a tweet is positive or negative. I can make an sentiment analysis on this tweet when I hold it, and then save it to other places in the database. Or I can have some field like positive or negative, and then when I query all the positives. But I don't store it raw data in the database, and then the queries are crazy. So we can also do some analysis to enrich the data to maybe make it in some schema that we want to use. Let's say, for example, that I don't know, like our use case before, the bank. Okay, so I have many sources from transactions to come from. I have these ATMs, and I have wire transfers, and everything is with different schema. And in database, I have one schema, so I have to do some change and save it the same way in the database. All the changes are inline, are on spot. When I see the data, I have some component detect it takes the data, switch the schema, and then stores in the database. Otherwise, I have many fixes to do after. So streaming, it's also not only to have some calculations, it's also to make some order in our data. It's to change the schema, is to enrich the data. We can do all this process inline, and then to store the data in databases, or maybe even to split them so the queries will be easier. I hope I answered the question.
Yeah, yeah, that makes sense. And so is it about like, so like you mentioned a particular use case. So correct me if I'm wrong. So when we have like more complex computation and analysis, for like a longer period of time frames, in that case we are like, okay, batch data processing is the way to go. Or when we have to just do simple reporting or computation, is that what streaming is used for? So
Mm-hmm.
is there like a, so can we do complex uh, analysis when it comes to
Sure,
streaming data?
sure.
Because how would that work in terms of space complexity? Because it has to be like latency should be in around like milliseconds.
Exactly. Okay, first thing, we have the advantage of the big data that is big. So if you ask me how many, if I have billions of records and you ask me how many distinct elements you had, and I had 2002 distinct elements, and I tell you 204, it's not much different, right? Because when I talk about huge data, if I am wrong with one element, it's not the worst case, right? I want to know, just like in terms of size, how many distinct elements I saw. So usually when we talk about big data analysis and we want to know we want to answer some questions, we can use estimating algorithms. Then we use the probability methods that we have, and we collect some sketches at the side, and then we add some averages, and we use methods of probability, and it works great because we're talking about big data. So I'm sorry for getting inside the statistics and classes, but when talking about expectations, it usually converged. So it's okay. It works great. And there are many interesting algorithms to find distinct elements and counting elements. Let's say I have billions of records and I want to count how many records I've seen, right? So if I have some counter, I always add 1 plus 1 plus 1 plus 1 plus 1, and I have this huge number, right? And we know that it takes log of bits to store them. So we can use some estimation algorithms in order to save log. So it's much lower space. And this is the main thing of the steering processes. And I think I find it very, very interesting. And like, as I said before, mind blowing to take the statistics and the probability and to combine it all together in order to know something about the data that we see and use every day.
Amazing. And since we're talking about it, like if we talk about companies and we're talking about the complexity analysis, so is there like a way to work with both of these, like batch and stream? So maybe reduce the complexity in the batch processes
Sure.
using maybe like a stream inline data enrichment method?
Sure. So we have few options. Okay. The first thing is sometimes use cases are not requiring a batch, so we can do everything that we need with our stream, and then to save it in some place, and maybe to show it in our app, and show it to and send it to different components, and everything is okay. Sometimes we must have some batch process, and in this case, I recommend doing to think before it what we want to do, what is our use case, and what queries we are going to do on our database, and then to think how we can enrich the data, how we can speed the data, how we can drop elements in order to our queries to be easier. Even to think about the schemas, because when we have many data sources, the schemas are different, so we want to make it all the same, and then to store it inside the database. Sometimes it's not a relational database, and then the schemas are different, and it's difficult to fix the things. And sometimes we can use things like sliding windows. What is sliding windows? It's like small batches of data that we always keep small batches of data and moving the sliding window, and then we can find, it's like small batching process on different collections of the data of the stream. And sometimes the stream changes, and it's good for us to know in times, like you asked me about the stocks use case. So in stocks, it's very good to do some sliding windows. This is very traditional method for calculating things about stocks. So actually, it's even fits, because people who analyze their stocks, brokers or something, or other people are using sliding windows. So it fits the streaming method. So we can find some, we can discover information about our stream in sliding windows. And we can also use some technologies to do it. So if I'm talking about, let's say, message broker. Okay, so our message broker, for example, Memphis, this is a message broker with some persistence. I can say, we call it stations. Stations is Memphis's queues, okay? So we can, when we create a station, we say, okay, I decide about the persistence. I can say my persistence is 1 hour or 1 week. So after the record enters inside the Memphis station, after 1 week, it disappears. So it's exactly sliding windows because there will be new elements, and I can do some calculation on my station. So if I calculate every week, so I have data of the last week, and if I'm doing some daily analysis, so I have sliding windows, exactly the method, but it comes like this for message broker.
And when we're talking about message broker, how like, so if you're talking about like organizations, right, and they obviously need to, work on a more modern and real time architecture, because they need the full potential of what their data has to offer. And we talk about data, there's so many things that people have to keep in mind with all these now strict rules and laws and everything as well. When we talk about like a message broker, what's like um, the implementation? What does that implementation looks like for stream analysis, or why, or where does like Memphis come into picture? Like for example, when we're talking about using the data streaming applications, like when we're
Mhm.
building data streaming applications, there might be some challenges associated with it, right? So can you tell us a little bit more about what are the top challenges that you have seen companies face when building data streaming applications, and how Memphis can help with that?
Sure. Well, usually when we're building a data app, there are a few components, and each component responsible for something else. Let's say, for example, which use case you prefer, the Twitter or the bank?
Let's talk about like if for I mean
Twitter.
let's do
Yes, Twitter. It was
because,
our first use
yeah,
case, which made us build this
yeah,
entire thing.
because yeah, no, I was just saying that in like top challenges, let's say we can also take the more obvious ones, that is,
Mhm.
that the
So text
application need to
analysis
be
is
good,
a very good
yeah,
challenge
like
because then it
scalability and and durability and fault tolerance and stuff.
exactly it helps with logs and with everything. So we started with Twitter. It was very easy with Twitter. We have an API. It's great. We take it out of the API and send it to our first component, which is the first component is the collector. Okay, so we collect data from the API and then we send it to our analyzer. Okay, so analyzer is the main component, which was the engine of the application, and it did some analysis. Okay, first thing was sentiment analysis. The second thing was LDA, which is topic extraction of the data. Okay, so we worked like in batch and stream because we had the data comes in stream, and then we put it, and then we sent it to the database, and then we took it out of the database. So this is like the first wrong thing that I talked about a few minutes ago. So we took the data out of the database and performed the LDA. So it was great. It worked nice. We did it every day. And then we decided to add Facebook. Okay, so now first thing, we put it inside the database, and then we took it out, and then the LDA didn't work because the schema was different. So we saved it as it was, the raw data, and the schema was different. So we had to add another component that changes the schema. Okay, so it was like we're taking the data with the collector, then inside the collector, we're changing the schema, then put it in the database, and then the analyzer takes it out of the database and analyzes. Great. Third place, we wanted to take Telegram. So we took the data out of Telegram. Third schema. So now our collector had three schemas and changed the second one and the third one. It became too complex and it shouldn't be like that. So we said, okay, we need three different components. One is to extract data from Twitter. Another one is from Facebook and change the schema. And the third one is to take out. So you can imagine how the scale is different, many components to manage, many schemas to manage, and then everything has to be online. And then we put it inside a database, and the database is not too big, but we have already some thousands of records, and then the analysis was heavy. The queries were heavy. So then we understood that the components have to work with something that makes the things easier. So then we decided to think about the message broker. What is a message broker? Is the things that moves the data from one place to the other place, from one component to the other component. So we know that we have some collector from Twitter, and it moves to one component, and then the collector from Facebook takes it to the other component, which is the schema change, and then send it to the same place. But it makes the work easier. It makes the scale easier because we can scale each component. The data is stored with some persistence, so I can take the data from, let's say, from our queue, which is the station. We can show it in the UI, and we can send it to some analysis, and we can trace the flow. So it made our life easier. But again, the solutions weren't good enough for us because they weren't easy to implement, and we saw that instead of focus on the use case, we focused on the message queue or message broker. And that's what we wanted to our users not to be focused on. We want our users to be focused on the use case. We want our users to think before it, what is the use case, how they want to analyze the things, what they want to show. And we help them just to transfer the data between the stations, the different stations. This is why we call it stations.
Cool. Amazing. Um, all right. And in terms of like, uh, when we're talking about data, when you're dealing with data, you have to keep in mind like, there's so many rules and regulations around it, and so many things come into the news and stuff. So what
Mhm.
are the things that you have to take care of when you're processing this data from a, let's say, more legal standpoint, making sure that we're all complying with um, the rules and regulations.
So, of course, when we talk about data regulations, it's we must say the word GDPR, of course. If there are European, actually, it's not only Europeans. It only every company that collects data, which includes data about with some information about European citizens, well, has to think about it. And actually, I recommend it to everyone that uses data, even if it's not including in your app, and you only want to know who entered your website, for example, and you want to keep logs. And we have to okay, it's the world of collecting as much data as we can, and we know that the huge companies are collecting data and profiling us. But in my opinion, and how I see life, we must be very, very careful with when we collect data. We must be very, very careful when we collect data about people. When we put cookies, I think it's something within people before we talk about technology and apps and everything. And of course, there are many regulations like GDPR, and I'm not sure about the American one. And when it becomes more dangerous, the regulations are getting more and more regulations. And I think it's important to have these regulations. So let's say that first thing that we have to do is to know what are the regulations. The second thing is is to keep only the information that's important for us. And when we do it, we have to reduce all the personal information. If I have ID of a person, I will do some hash function of this ID and maybe store the hash and not the ID. If I want to know if this person came to my website again, I can store the hash function because I'm not interested on this ID of this person or the IP. I'm not sure if I want the IP. Things like this. Also, I recommend to have inside companies position of CISO, or someone who is in charge of the information and not to be cheap on this one, on this role. Also to consider which cloud we use to see that it's secured and also compliant. The big clouds are compliant, but if I use third-party apps, I have to see also to make sure that these apps are also compliant. And also, for example, for our solution is you can install it in your VPC or install it over Kubernetes. It's cloud native. So if your cloud is secured, so the data also secured, and all the messaging system also secured. You can install it with Docker on your computer. So you should think about it, okay? So not only think about the use case, think about how you can, how it compliant and how you save information of people and not put them in risk. There are too many cases of credit numbers and things like this that were broke.
Yeah, couldn't agree more. I think the US has something like I think called CCPA. But yeah, cool. Well, it was great talking to you, Sveta, and thanks a lot for sharing all the insights. For everyone else who wants to get started with Memphis, check out the links in the description below. Do you have any closing remarks?
So as I said before you're starting to develop your application, think about the use case, understand what are the requirements, which components you need, and how to move the data between them. How can you reduce the time complexity and the space complexity, and enjoy.
Yeah, awesome. Yeah, well, amazing work, and really appreciate you giving the time. Thanks everyone else for joining and watching as well. And if you have any questions, you can leave those in the comment below. You can also join the Memphis community. All the links you can find in the description below. And we'll see you in the next one. Have a great day. Bye.